What's going on, everybody, and welcome to part 40 of our machine learning tutorial series. In this video, we're going to be continuing to talk about the mean shift clustering algorithm. And to start, we're going to revisit code from part 36. And basically, we're going to take everything down to the fitment or fitx up to the top, copy that code, and paste it in here. If you don't already have this, you can either go to the text-based version of this tutorial, or you can go to part 36. It doesn't really matter. We're going to change a couple of things. First, we're not using k-means. We're going to be using mean shift. So, whoops, where is my mouse? There we go. Mean shift. Also, we are going to be making a copy of the original data frame, which we'll do basically as soon as we read in Titanic.xls. We're gonna, and before we drop body and name and all that, we're gonna make another addition, and that's gonna be original underscore df is gonna equal pd.dataframe.copy df. Again, we can't just say original df equals df, because as you modify df, it will also modify original df. So we do this to copy that data frame. And the reason why we're doing that is, first, we want to feed it through mean shift, which will cluster our data for us. But then after that, we want to look at the information. We want to see what it found. And I don't know about you, but I prefer to read things in text form where they're used. Okay, so we could get by, using zeros and ones and twos and threes. But for like where they departed from, where their cabin was, where they male, female, and all that, it's just easier if it actually says the word for us. So we're going to do that, and then we can kind of reference these by index later on once we've made the classifications. So we do that. Also, mean shift for the classifier down here. No longer are we doing k-means, it's mean shift, and we get rid of n clusters. Great. So that should be all we have to do for now, or at least, to modify the code. We're done. That's it. Well, really, that is it, because actually you fit mean shift and we're done, right? But no. Okay, so you guys, I can hear you laughing from here. Now, labels is clf.labels underscore. So that just gives us the labels, and then we're going to say the cluster centers equals clf.cluster centers underscore. So nothing really new there. And now we're going to add a new column to that original data frame. So we're going to say original underscore df. And we're just going to say this is cluster group. So it's just a new column. And for now, that column is just empty. It's going to have not a numbers in it. npnan. No prob. So now what we're going to do is we're going to iterate through the labels and populate the values in of this column as those labels. So what we say is for I in range of the len of x, what do we want to do? Well, we're going to say the original underscore df cluster group dot iloc I equals labels I. What the hell am I doing? Okay, so what happens here is we're saying with iloc, we can reference basically the index of the data frame, but really this is the row on the data frame. So iloc, and let's say I is equal to 0. That will be the 0th row, right? That first row in your data frame. That's what this is going to reference, and it's going to say, okay, in that first row of the original data frame, under the column of cluster group, we're going to set that value equal to whatever labels I is. And again, labels is just right in order of X as well. There's no shuffling or anything going on here. So that's why we're doing that. So now, the first thing right out of the gate that everybody's going to want to know is, okay, so we've created cluster groups. The question is, natively, remember with k-means, when we said we wanted you to classify these into two groups, we said, hey, we're kind of expecting these to be survivors and dyers. And sure enough, to about 70% accuracy, that is what it did. But here, I'm going to show you what the power of mean shift. And k-means possibly could have found similar results, but it's less likely. But anyway, here is the power. So first let's say survival rates. And of course the question is here, obviously it might make 2 groups, might make 1 group, might make 5 groups, 10 groups, whatever. But then when it makes those groups, we can kind of start diving into those groups. So you'll see what I mean here in a minute. But for now, survival rates. And this will just be, the key will be the cluster group index or the cluster group number followed by the survival rate. So just really simple there. And then what we're going to say is for I in range n clusters, n clusters underscore, I believe. Did we even define? And we probably better define n clusters. So we're going to say n clusters equals the len of np.unique labels. So just however many unique labels we have, that's how many clusters we have. So then for I in range of those clusters, we want to, first we're going to say temp df equals original df. And then this is an original df where the original df cluster group is equal to the float of I. So this is just a conditional statement that just says we're creating a new temporary data frame where within the original data frame the cluster group was equal to this. So basically it's a new data frame which only contains, let's say the I is 0 for first, so this temporary data frame is the original data frame only where the cluster group is cluster group 0. Okay, so that's just your quick temporary data frame. Now what we're going to do is we're going to say survival underscore cluster equals temp underscore df. And again, this will be another little conditional data frame where temp df survived equals 1. So the survival cluster data frame will be where the temporary data frame, which is the one where that's just specific cluster that we're curious about, where the survival rate was, or where they survived. One was that they survived. So that's the survival cluster. And then we can just do survival rate equals the len of survival cluster divided by the len of temp df. There's a few other things that you could do here, but later on you might care to actually have that survival cluster data frame and the temporary data frame, but there are a couple other ways that you could get just a survival rate. This is just one way, so feel free to do a different way if you want. So that's your survival rate, and then what we're just going to say is survival rate I is equal to whatever that survival rate, whatever that rate actually is. So now at the end of this, we're going to print survival rates. Now I will just say, because mean shift has a slight degree of randomness, you might not get the exact same results I get. And that is going to be true when you actually process real data. You're going to get different results different times. So I'll go ahead and run this, but don't be freaking out if you get a different result. So first we're getting that warning about the numbers stuff that I'm ignoring. And then we come on down. Here's another, okay, so we're setting values on a copy of a data frame. Again, I'm not worried about that. So in this case, we get 3 major groups, group 0, 1, and group 2. And we can see in group 0, their survival rate is 37%. Not horrible, but not great. Group 1 has an 84% survival rate, which is actually really good. And then group 2 has a 10% survival rate. Now, I'm going to go out on a limb here, and I'm going to wager with you fine individuals that group 0 is mostly second-class passengers. Group 1, with the 84% survival rate, is probably mostly first-class passengers. And then group 2 is... Let's see. Sorry, I'm getting confused already. 0, cluster, second class. Cluster 1, first class. Cluster 2, third class with the worst survival rate. That's what I'm thinking is going to happen here. So we can't really leave this. This would be an example where all the people wishing I used IPython. This would be a little more useful, but we can continue working in the interactive shell from this point. You could also have this code over here, but again, each time you run this, it's going to be a little different, okay? But we'll continue on with this example. So the first thing that we could do is we could say something like this. We could say we want to see print. Well, first we can do this. First we'll say print original df. Let's see. No, print original df where the original df cluster group is equal to, and let's visit group number 1. I believe these will be our first class passengers, but we'll see. Coming up here, so this is the group. Okay, sure enough, this is the full group. Every single individual in this group is indeed a first class passenger. Nobody saw that coming. Okay, they're also mostly female. So a couple of things to note. Again, just because they're first class, I mean, this isn't an issue on rich people always win necessarily, but first class was just at the top of the boat, so they were more likely to actually get a lifeboat because they were on the level that needed a lifeboat. Conversely, as we're hopefully most likely to find, group 2 is going to be mostly third class individuals. So we can do Alt-P and look at group 2, but group 2 is probably going to be bigger, but let's just do it. That's not so bad. So sure enough, group 2 is all third class individuals. Only one of these people actually even survived. But again, 100% that they are third class individuals. And then it's likely that the group 2 is going to be, well, group 2 is going to be a huge group, but we're going to wager that it's mostly second class. But obviously this isn't all of the third class passengers, and obviously this is not all of the first class passengers. Okay, there's probably more. So anyway, we're going to come down here now, and then what we're going to do is we're going to do Alt-P, and I think we're curious, which one would we, okay, so group 0, we're thinking that's probably second class, obviously. That's going to have everyone else, basically. So we could look at group 0, and we're printing original df, and then we're going to do .describe. Okay. So that'll give us a little more space to deal with. Okay, so here we're working with 1,280 people. The mean of the class is 2.3, so sure enough, pretty close to class 2 in general. But we do have everything. We've got some first class passengers, and we've got some third class passengers. So we have both in this group. We can see some more information, what the average age of this group was, and then we could do the same thing. Like we could get the average information, like with describe. This just gives us stats on the data set. I think first was that first class group. Yeah. So again, the average age here is 37, so they're a little older people in this group. And then we could do the same thing with I forget already what the other group was. So 0, 1, so then 2. And again, we can see that this group is actually a little older too, 39. Okay, so then you might start getting curious. So for example, if we look at, this is group 2, which I'm going to go ahead and print the survival rates again because I already forgot what they were. So print survival rates. Right. So for example, with group 2, group 2 is the one that basically most people died, right? This is your third class passenger. Interesting thing to look at is maybe looking at fare. How much money did these people actually pay? So here we can see the minimum was 29 and the maximum was 69, and this is in British pounds if I recall. So that's the survival rate, that's the fare for group 2. And then looking at group 0, which is mostly second class passengers, as we believed, we can see again, going to the fare, we can see that the, I'm so lost. The minimum is 0. Apparently someone got on there for free. I don't know what's up there. And then the max is 263. So this is 0 to 263 for the fare. And then if we do the same thing again, only this time on group 1, and and keep in mind, 263, this is including some first-class passengers, because this data set did include, or this cluster group did have some first-class passengers. But now looking at this group of first-class passengers, we can see the minimum was 247 pounds paid, and the maximum is 512 pounds, with the mean being actually 312. So the people in this group appear to still be a slightly more elite group of individuals. And the same is true here. If we look at the mean of the fare here, which is actually let's see, which one was this one? This was our second class. So the mean of the fare was 29. And then I wonder if we looked at the mean of the fare for group 2. Fare, the mean, well, actually, these people paid a little more money. That's interesting. I wonder if it has something to do with that 0 fares. I wonder if someone actually got on for free, or if that's like missing data. It's probably missing data. But anyway, so interesting. And then with that missing data from group 0, I wonder if that would affect the fare. But I would wager probably not. So, and the other question we could ask is something like, what would be the survival rate of the first class passengers in this group 0? So, for example, in cluster 0, remember the survival rate was 37%. But what if we asked what was the survival rate of first class passengers in this cluster 0, for example? So you could have something like this. You could say, let's see, cluster 0, and you could say, we could say cluster 0, or possibly, let's say cluster. Sorry, I'm trying to decide what I want to do. So first, we could take this here, and then I could say, cluster 0 equals this, only this we actually want, I think, group 0, if I recall. Yeah. So that's what cluster 0 is, and we need to close this off. Let's see. So here. Okay. So that's cluster 0. And then we're going to say cluster 0 FC equals, and this would be cluster underscore 0 equals, oops, cluster 0 where within cluster underscore 0, and then this was P class places. Wow. Okay. This will be the last tutorial of the day as well, apparently. Cluster 0 P class equals 1. So first class passengers. Okay, and then we would say cluster underscore 0 underscore FC dot describe, and this will actually give us the survival rate as well. So here, survived, the mean of this is 60%. So 60% of the first class passengers in cluster 0 survived. So that kind of gives you a little bit of information on, still if the upper bounds of the survivors within cluster 0 were first class passengers. And then of course you'd have to ask, like, is that survival rate, you could do the same thing for, rather than cluster 0 first class, what about second class, third class passengers and stuff like that? What was their survival rate in this group? But for the most part, it appears to me that the group is largely classified based on the fare, but there's probably some other information in here of like what these groups are actually classified into. But still, at the end of the day, we see these groups are classified into P class, but also to some degree their survival rate. So anyway, now what I want to do real quick is, remember, this created 3 groups, and then this was the the survival rate, right? So 0, 37, 84, and 10%. Let's just run it one more time, and then just see if we get more groups. And then, right, we actually wound up with an extra group here. So we still got 37. This is probably the second class, the bulk of the data, most likely. And then this one actually has a group that survived 100%, which is pretty interesting. So we could take, let's see. I wanted to see this. So let's take this copy. I'm just going to come down here, paste, and we could look at group 1. And I don't want to describe. I want to see who this is. Ooh. So we have some people basically on 2 different tickets, but otherwise these are all together people. These are their fares. The other interesting thing I wonder is with the fare that it is, like we can see that this is a ticket for 1, 2, 3, 4 people. So their fare is higher, possibly. I don't really know. So it might not even be the case that these are the truly elite people, but it turns out that that seems to have a pretty decent impact on their survival rate. Like maybe it's how many people were in their group. I really don't know, but you can keep digging into it and find out. But anyway, these people had 100% survival. That's pretty crazy. Interesting. So, I'm trying to think if there's anything else I really want to point out. And then really in k-means, we kind of already figured out that male and female, for whatever reason, didn't really seem to actually play a huge impact in those 2 groups. And then when we took away like the lifeboat and all that, the 2 groups were still relatively consistent. So pretty interesting. So anyway, that's it for this tutorial. If you feel free to like dig around, and you can probably find some more interesting things in this data set. It's a pretty popular data set. People use it for all sorts of analysis and stuff like that, because it's kind of common that you'll get a data set that just has a bunch of information on people, and you don't really know, you might not, or not just information on people, but information on just things in general. So you can use clustering to kind of group those things together, and then you kind of start going into those groups and see like what makes up these groups. Why are these being classified as groups? Because in this case now we have 4 total groups, and also if I was to, I bet if we do 2, this will probably be 3rd class individuals. Sure enough, yeah. So you can see it's continuously giving us these similar groups where at least the least likely to survive are the cheapest people in 3rd class, and so on. The most likely to survive apparently are the people that paid the most for their ticket. So interesting. So anyways, that's it. Questions, comments, leave them below. Till next time.